Good morning, friends. Today we'll be seeing an application problem in projection of straight lines. So the problem is we have two roads start at a common point A. Road AB is 3 kilometers long and bears 50 degrees southeast on a downward slope of 30 degrees. Whereas road AC is 1.8 kilometers long, bears 55 degrees northeast on a downward slope of 20 degrees. What is the length and slope of the connecting road B and C? This is the problem. We'll be solving the problem using the concept what we studied in engineering graphics. I am very happy to show you a model. So this model itself will define the problem completely. So here I have the point A, this is the point B, this is the road AB. The road AB is having a length of 3 kilometers and it is having a downward slope of 30 degrees. The road AB, when you look from the top, it is at an angle of 50 degrees southeast. This is road AB. We have another road AC. So this is my road A, this is my point C. This road AC is having a length of 1.8 kilometers. It is having a downward slope of 20 degrees. And this road AC, if you look from the top, it is at an angle of 55 degrees northeast. So we have road AB as well as road AC. Now we have to connect the point C with B. Otherwise we have to lay a road between B and C. This road BC, we have to find out the length of the road. We have to find out what is the slope the road makes with respect to the ground. Now from the model, we have made the model to a scale and we have seen that the road BC is having a length of 2.85 kilometers and the angle of the road with respect to the ground is 18 degrees. So this is the answer we got in the model. Let us see whether we are getting the same answer by using engineering graphics also. I hope that problem is well defined with the help of the model. Now let us go to Open Drive and let us start drawing the road AB as well as the road AC. Then we'll connect BC. We'll find out the true length of BC. Now let me go to Open Drive. So this is the open board. Now let us use this open board and let us solve the problem. Let me assume that the point A dash is here. This is the front view of the point A dash. Now I will be assuming that the road AB is parallel to vertical plane. Thereby I can see the true length of the road in the front view. I can also see the true angle of the road theta. So that is what I will be doing now. So I will be having the point, say I will be drawing a line for a length of say 3 kilometers at an angle of say 30 degrees. So let me do that. So here I have the point A dash and let me mark this point as B1 dash. So this A dash B1 dash will be having a length of 3 kilometers, and the angle of this will be 30 degrees. So while the road AB is made parallel to VP, I have seen the true length of the road in the front view. I have seen the true angle 30 degree also in the front view. In that case, the plan view of the road will be parallel to XY line. So let me draw the point A in the top view somewhere here. Then I will be drawing my plan view of the road. So this will be my plan view of the road. So this is the point A in the top view. So here the point B1 dash in the plan view will be here. So let me call this as B1. So this is my plan view of the road, but the road is at an angle of 50 degrees southeast. So that means from the point A, I will be drawing a line at an angle of 50 degrees. Let me draw that line. So from A, I will be drawing a line at an angle of 50 degrees with respect to vertical. So this angle is 50 degrees. So this is north, and this is east, and this will be southeast at an angle of say 50 degrees. So that means the point B in the plan view will be lying somewhere here. I know what is my plan length. Now I have to take A as center, A B1 as radius. I have to draw an arc. So now I can draw an arc of radius AB1 with A as center. I am cutting the inclined line drawn at an angle of 50 degrees. So now I will be getting my point B in the plan view. So this is my point B in the plan view. Now the plan view of the road is drawn, whereas this is my point B1 dash. So the point B will be in the front view will be anywhere on this line. So to get the B dash, what I do is I am drawing a vertical line from B. So it will be cutting here the horizontal line. So the intersecting point will be B dash. So let me call this as B dash. So now I can join A dash with B dash. Let me connect A dash with B dash. This is the front view of the road AB. Likewise, this is my top view of the road AB. So now I have drawn the projections of the road AB in the front view as well as top view. In the same way, let me draw the road AC. Now the road AC is having a length of 1.8 kilometers. It is having a downward slope of 20 degrees. So from A dash, you draw a line at an angle of 20 degrees for a length of 1.8 kilometers, and let me call this point as C1 dash. So A dash C1 dash is having a length of 1.8 kilometers and it is having a downward slope of 20 degrees. From C1 dash, if I drop a vertical, so let me call this point as C1. Now AC1 will be the top view length of the road AC, whereas road AC is northeast at an angle of 55 degrees. So now what I do is from A, I am drawing a line at an angle of 55 degrees. I will be getting a line like this. So if you measure, this angle will be 55 degrees. That means the point C will be somewhere here in the top view. I know the length of AC, this will be the length of AC. So let me take the compass again. Let me fix point A here. Let me draw an arc with A as center, AC1 as radius. I will be getting the point here C. So this will be my point C in the top view. So now I have the road AC in the top view. Now once you get the point C, then from here you draw a vertical line from C. So that vertical line will be cutting the line, horizontal line drawn through C1 dash. So from C1 dash you draw a horizontal line. This is the main line on which I will be having the front view of the point C. So from C you draw a vertical line. The intersecting point will be my C dash. So this point, let me call it as C dash. Let me use a different color. Now I have the road AC in the front view as well as top view. So this is my top view of the road AC. This is my front view of the road AC. Now what you do is, I have road AC, I have road AB. What we have to do is, we have to connect B and C. Now let me connect with a different color the road B and C. So this is my C dash, this is my B dash. This is my point C, this is my point B. Now I have the road BC in the front view as well as in the top view. But now the road BC, I have to again make it parallel to VP. So what I do is, so with B as center, BC as radius, let me draw an arc. Let me use a yellow color. So with B as center, BC as radius, let me draw an arc. Let me bring the compass again. Now I fix B as center, BC as radius. Let me draw the arc. So the arc comes like this. So this point, let me call it as C2. Okay. Then from C2 you draw a vertical line to cut the line drawn through C1 dash. The intersecting point will be my C2 dash. Now I have the point C2 dash, B dash. If I join, let me use a red color. This will be the true length of the road BC, and if I measure this angle, this will be the true angle the road BC makes with respect to the ground. So if you measure, this length will be equal to the true length of the road BC. So it appears to be having a length of 2.85 kilometers. So if I measure it, I am getting a length of 2.85 kilometers, and it is having a slope of 18 degrees. So the answer for this problem is B dash C2 dash, which is the true length of the road, which is 2.85 kilometers, and the angle BC makes with the ground is 18 degrees. So the same answer we have got in the model also. So if we refer this model BC, the angle is 18 degrees and the length of the road is 2.85 kilometers. So we have drawn the drawing, thereby we have found out the length of the road BC as well as what angle the road BC makes with respect to the ground. I hope you have understood the problem as well as you have understood the answer also. With this concept, you can solve any problem in projection of straight lines. So thank you. Good day.